Welcome to a Modumate tutorial about how to build roofs. In this tutorial, we'll be building a hip and valley roof system over a fairly complicated building footprint. Now, in this tutorial, I have not pre-practiced how to model this roof, so you will see me reason through some of the unknowns around modeling roofs. Anyone who's modeled buildings in 3D knows that roof geometry and trusses and so forth is a little bit complicated, and every floor plan causes different strange shapes and triangles to emerge in the actual water shedding planes of the roof. So we're going to be modeling this. There's a very basic set of workflows that allow you to build up especially right-angled floor plans. That will be the focus of this tutorial. We're going to choose a roof slope and then model some construction lines for ourselves to use, and then add them to the floor plan and start to build up a roof using them. In this case, we'll be modeling with a 6:12 roof, but the same principles apply with 4:12, 8:12, 2:12, every other common slope ratio that comes with prefabricated trusses and construction conventions. So when it comes to modeling the hips and valleys of a floor plan like this, we are going to draw a construction line that is large and probably overkill for any particular hip or valley of this roof plan. This is actually two different floor plans, but I added a second story onto this first floor just as an example for what if you had a building with different kind of roof bump outs and multiple levels of roofs. But we're going to start by just enclosing this one-story building with a pretty unusual floor plan shape. This 6:12 roof is going to need a construction line that has a slope of 6:12 in not just one direction, but two. So I'm going to use my line tool, and I'm going to draw myself the construction line out here in space. I'll click on the ground. I'm going to come over, I'm going to say 40 feet, and then go up 20 feet. So I'll type 20 feet, enter, and then I'll go across in the third. I've now at this point constructed a 6:12 slope in one direction, which would be appropriate if I were modeling gables. But because hips and valleys will actually be receding in all three dimensions, I'm going to go 40 feet the other way as well. So this is the magic kind of one dimension at a time construction for a hip or valley along this particular direction. This line represents the slope where two different 6:12 trusses would meet. When you have a 6:12 truss looking north here and a 6:12 truss looking east here, those two truss systems will come together and cause a hip or valley with this kind of slope. So these three construction lines were what I used. I no longer need them though. And the next major truth about building, about roofs, is that there will be four different cardinal directions where these slopes will exist: northeast, southeast, northwest, southwest. So I'm going to move this actually kind of out into space here just for clarity. I'm going to copy it a few times. Let's go like 10 feet over just for the way I'm using the copy tool there. I've selected the objects. I'm typing MV to enter the move tool, or selecting the move tool from the dropdown, clicking a start point, and then pressing the control key and releasing it. And that turns my move into a copy. So I've now created four different sloped lines. They're all parallel. But the next step is to use the rotate tool and rotate them into four different cardinal directions. So I'm going to type RO for the rotate tool, or click the rotate tool here. Choose the center of rotation and rotate it 90 degrees. Press escape to leave the tool and escape to deselect my object. Then I'll type RO again, and I'll click and I'll go not 90, but instead 180 full degrees here. You can see that I'm creating construction lines for the different sides of this roof's hips and valleys. Lastly, this one here, RO, click, choose a reference direction, go 90 degrees out. I now have four lines that are very likely to be the directions of my hips and valleys for this roof. So what I want to do is grab one and start copying it into the right locations on this roof. Now here I do not have any eaves yet drawn. If you have, different people design their eaves differently. If you prefer for the footprint of your building to load directly onto the wall, then you can just basically model from these points, which is, you can imagine this is where load will bear down onto the walls. If you did want to measure all of your roof slopes and get a significant overhang to your building, then of course you'd model the overhangs. Perhaps it completes certain shapes or bump outs, or there's just a uniform kind of 1.5 foot or some, common distance of overhang. You'd model all that out, using your line tool and creating extra 2-foot overhang here, and then keep on going around the building, etc., etc. Just modeling the overhangs of the building line by line. I'm not going to do that. I'm going to model a roof that comes to load directly on these walls. And I'm going to grab my first edge, and I will press the MV key. I will click here at this bottom corner, press Control, and now I'm copying this line. And I can kind of see with my mind's eye which edges are likely to involve this particular roof slope. I'm copying to these corners because when I look at a hipped roof system, it's likely that the roof would slope up from these corners across the building. You can kind of see just which direction goes into the perimeter of the building's footprint. So I think those are my primary corners. If I missed some, I can come back later. This edge, I will do the same thing, and I will look at this back corner over here, and here, and here. I think those are my primary corners that have that type of slope. And then I will come over to the third edge, grab it from its base, press Control with the Move tool to make it a copy. I will come over here and grab these different edges that are sloping up and in. And I think I've got most of those now. And then the fourth one, over here, I will copy in to the corners here, here, here. I suppose arguably here and here, yep, those deserve to exist. Did I miss this click? Nope, I got it right. There's one corner I missed here. I think this one here deserves the same direction as I started with, but I just missed it. So I'm going to copy that one up as well. So what happens is that you end up with a bunch of construction lines that if you kind of squint your eyes, you can see the way that they imply some of the roof shapes, but it's not complete yet, right? We need to add on extra information, and we're going to use the line tool to start connecting dots and then giving these extra lines a haircut once we know they no longer are needed. I like to start from the easy and well understood sections, such as these small little bump outs. It looks pretty obvious to my intuition that this little wall here that's 4 feet long is going to cause a 4 foot long ridge on top of this roof. So I'm just going to draw, I'm going to use a line tool, hotkey LI, then I click at this point, travel through space, and I'm going to hold shift and mouse over to the next construction point I hit. When I click there, indeed, I have completed an extra face here. I can kind of now see with my mind's eye that there is, from this point, it is very likely that this roof slope here above this wall is going to connect this edge and this edge, but by kind of rising through space with one line that's missing. From here, it seems likely to me it will rise up and away this way until it meets the projection of this edge. You can see how they're all in plane. What we need is this same kind of line that existed on the previous point to get copied over here. And as I find more and more information that makes sense to my eye, I'm going to basically be copying these different ridges. I have all 4 cardinal directions here. I'm going to copy the one that I need into the right places. So as you can see here, this edge just got copied into place, and as it crossed this edge in space, it formed a big old roof. Now that's too much roof in the end. I can tell with my mind's eye that this plane is hanging out in space in a way that doesn't make sense. This edge is likely to be kind of the boundary where we no longer need any more height out of this plane. So I need to use my line tool again and click from here along the green dashed line till I meet that sucker. And now I'm starting to see that there's a lot of material I can trim off the top of this. It's not clear to me exactly how high up this back wall goes though. So let's just take a look at some other simple, easy to pin down walls. I see here this 6 foot long edge is very likely to cause a 6 foot long parallel ridge up on top. So I'm going to go this way, hold shift, and just like suspected, there is a 6 foot long ridge. Similarly, this one looks like this little bump out here is 3 feet long. I should expect to see a 3 foot long ridge there too. Yep. And now I think what I'm seeing is that this line and that line are going to be a valley together, but it's not crystal clear to me yet. What happens when I copy this line from this point to here? Hey, look at that. By coincidence, I just used the more rigorous means of constructing this. And yep, this point and this point coincidentally happen to perfectly meet. I don't think that that always happens. That's just a coincidence of the sizes of these walls. But it helps pin down the fact that yes, this roof here is how this part of the building is almost certainly covered. And then I am seeing a bit of an overkill triangle here, so I don't think I need that. I'll just delete it. I'm going to go to this front bump out here, and it looks to me like this 10-foot wall is likely to have a 10-foot ridge up at its top, meeting somewhere over there. So I'm going to go draw a line here. I'll go across 10 feet. Yep, that looks like it. Now this other wall here was only 8 feet long, so it appears that the roof slope over here is going to be interrupted 2 feet sooner, and something's going to start rising up from this point in probably the other direction. But for now I'm going to focus on closing out this plane that looks to my eye like it's very close to being closed. I suspect that from this point, some roof is going to want to rise up and to the, I guess that's the northeast. So I'm going to grab a similar northeast edge and copy it that 2 feet over. Hey, look at that. Yes, indeed, it intersected all the other planes. It also caused a bit of overrun. And at this point, I'm starting to see that we have maybe more lines than we need. And a lot of the simpler corners of the building have been closed. There's no longer any question in my mind how this part of the roof gets covered. So I don't need these super rays projecting from it anymore. I'm going to kill that one off. I'm going to kill this one off, and it looks like it actually has been split before, so clicking delete twice to clear that one out. Similarly, this point over here seems like nothing about it could be changed by what we still have to do, so I'm going to kill that, kill that. Over on this side of the building, the first point we clicked on, this edge here seems like overkill. Frankly, they both seem like overkill. This looks like a foregone conclusion how the roof will be shaped. And there's a few others too. These two coming out of this point here seem like they're very obvious. This one too seems like there's no way I'm going to have any roof slope getting bounded by this green edge. So I'm going to kill that off. I don't need to go too far though. If I start to lose edges, then I lose clarity with my mind's eye what needs to get completed here. So from here, the next plane that seems to make the most sense to me is the back of the building here. It looks to me like this edge, this edge, this edge, this edge, and this edge are all coplanar. And if I turn my camera, I can kind of just like mock that up with my eye here. Yes, it looks like they're all in plane. But what kind of line do they need to, as a matter of fact, this top of the plane here is not necessary. I remember from the backside that it's all floating off in space. So I'm actually going to just do something that my intuition says is right, which is to trim that off. Yeah, at this point I can take this whole extra triangle up on top and get rid of it, and the lines that were zooming out from this point. So now the question becomes, is this a high enough high point to the roof? I'm not sure that's true, but what I will want to do is take one of my angled lines for the southwest direction, start to raise up a line from this inner corner here just to see what it tells me. As I do that, okay, it started to close out more of the roof plane. And then I've also got a ridge going on here. This looks like this one here is a perfect match. So I'm gonna, instead of drawing custom lines, I'm always gonna try to grab these construction lines I've built because they are the right slope, and if they enclose planes, then we're gonna have a very happy time. So this does seem like one of these funny little corners has just been wrapped around from the back side of the roof trusses to the front side of the roof trusses with a little bit of overrun just due to the width of this wing here. Anybody who's built a roof before knows that this can get confusing. But these lines seem like they are no longer super needed. And from here we're seeing a set of coplanar edges all kind of bounding the front of, if this were the front of the building, like the kind of entry portal next to maybe a two-car garage, then we want to bound all of this with a point here. In fact, I think what I'm seeing is that these edges are all coplanar. But, oh, not this one. But what's missing is that we don't have a line coming from this point up towards the lines that are nearer to my camera. All we got to do is grab this line and copy it back 2 feet, and bada bing, bada boom. Now, all those coplanar lines got met by a new one. But it looks to me like it's rising higher than the back side of the building needs, and that the ridge between these two is very likely to be due east in the project. So I'm going to come across this and kill this off. And so this looks like it's starting to get, whether this is the literal high point of the building or just part of it, I am now needing to turn a corner to help enclose what looks like an extension of this part of the roof due to that 2 foot difference in this 10 foot and 8 foot wall. So this little 2 foot jog here, I'm seeing this slope. This point, to my mind's eye, looks like it's likely to descend onto this nearer side and descend back onto the back side of the building. So I think the edge that makes all that come true is one that descends to the northeast like this. So I believe if I copy this, this won't be super precise, but if I copy this here, for example, hey, nice. It did what I hoped. It added more plane here. It also enclosed this plane edge to edge. So we're seeing now a small bit of plane here. This is the actual high point of this roof area. And what I think we need to do here is grab this edge. You'll notice that I am kind of, because I don't actually know the distance from here to wherever this projection is going to be, I don't want to grab this point because then I'm going the wrong direction and I can't specifically choose the right point here. I also don't want to grab this point because if I do that and target this point, of course I'm creating some extra intersections that might mislead me. So I'm kind of eyeballing the distance from roughly here to here. Looks like 6.7 feet or so. I'm grabbing a reference edge. I'm eyeballing where along that edge might be about 6.7 or 7 feet. And I'm pressing starting the move tool, pressing control. I'm now copying a line that is just a little bit larger than what I need. You can see on the left side that it's going to intersect my left side reference. When I click this, I have extended the roof plane a little bit more. And now I think what I've got here is just two simple triangles. There's the primary roof mass and this secondary roof wing that are technically both desiring to kind of shed downward. Now this is a bit of a no-no in the actual design of roofs. It is often better to kind of build up some kind of bigger roof. So if we do that, we are likely to want to just, what are the dimensions here? We've got a 9-foot length here, 6'9", 6'9", 6'9", 6'9". Oh, whoa, those are symmetrical triangles. And that makes sense because we've been dealing with symmetrical slopes at all points here. Everything is 45, 45, equal height. So if these 2 points exist, and all 4 of these lines rise in the conventional ways we've laid out, then they certainly will make matching triangles. And what we can do there is just cover the triangle up. And these 2 slopes have now been designed to continue shedding down this plane and continue shedding down this plane. So technically, the spaces beneath do not require this little area to exist. If you deleted it, you'd still have the ability to fully enclose your building. But this is just more logical for the shedding of water so that at no point does some kind of a valley that doesn't, one side of which doesn't begin draining, ever exist on your roof. Okay, I've enclosed the roof and I am going to now give it a haircut. I'm going to delete the top points of all these different lines that are zooming out in space. And I'm going to start uniting some other planes that technically are the same plane, but I built in little sections so they look split up. This line here I don't think is needed. If I delete it, it joins the 2 planes on either side. If I turn around, this looks pretty good. This line here does not look needed. I just added this in to help my eye see things in the moment. This line here is not needed, but I believe there's the underbuild or the shape underneath these 2 triangles that I must first get rid of. So I'm going to delete this edge just to make it easy to see. I'm going to then delete the triangles I don't need that are hiding under there. Then I will use the line tool and reconnect the edge I do want long term. Now, this edge only separates 2 faces, not also the lower triangles that we previously had. I can now press delete and have it heal the 2 edges side by side. Why is there a point here? Is there something underneath? Yes, there's an extra floating line from my kind of excessive grabbing of edges before. This line here, both of these lines appear to not be needed because all 3 of those planes are all parallel. So I'll delete this one and this one. Bada bing, bada boom. This one here too, it looks like it has 5 extra inches of stuff. I'll get rid of that. We're getting closer and closer here. This line is not needed because it actually unites the lower and upper coplanar faces. And this looks to me like it is the actual set of roof planes. So after the initial discussion, this did take about 15 minutes, but this here is the correct set of planes to cover this building. from here, if you wanted to add extra eaves, you can kind of employ the same technique as we did before and draw some overhangs. It depends what size eaves you're looking for. If you want to measure your eaves per the building's floor footprint, maybe it makes sense to do something like this. I'm going to come out 1.5 feet and then across 1.5 feet and then down half as much because the ratio is 6 to 12 in this project. So we'll go down 0.75 feet or 9 inches and connect back to here. Now we have an edge that will likely act as any of the hips to this eave system, and around each part of the building we're likely to have one of 4 cardinal directions we need. So I'll use the rotate tool, grab this hip, turn it 90 degrees. I'm now prepared to copy this hip around every edge that applies, and then copy the previously drawn hip around every corner that applies. And you can see here that as I draw them, I'm now ready to connect these awning points in a way that is 1.5 feet in ground plane projection back to the building. So I hold shift along the green axis while drawing a line here. I mouse over the wall, and you can see that the green direction projection of this line is 1 foot 6 inches. And likewise, holding shift along red, you can see that it's 1 foot 6 inches. And holding shift along green, you can see that it is 9 inches of descent. If you had intended for all of this to be included in the height of your roof, then at the beginning of this tutorial, I would advise that you model these overhangs beforehand, probably in a flat way, so that the point here is not 9 inches lower than the original point, and instead your eaves are flat. There is not a kind of concave underhang, but instead a flat underhang. And that would provide you a series of external points to start doing the exercise we just finished from that slightly larger set of points. But with this technique, you can see how the same set of copying and pasting diagonal lines is going to finish my eaves. You can see as well how the same technique can be used on simpler roofs. In fact, this one will take me much less time. So copying the same corners here, here, here. I'll grab this one and copy it here. I'll grab this one and copy it to the 3 corners over here. And I'll grab this one and copy it to the 1 corner in the back. Now, there's a lot of planes that already got completed because of how few jogs exist here. But what we're looking at now is that that edge there needs to be completed. And then this edge over here needs to be completed. And then we're likely to just need a little bit of second copying to get around this unequal sized jog. Boom, that's completed that side. And similarly, we're going to want, where's the matching direction here? This edge just needs to get copied over to here. Nope, here. And now you have completed this plane. We'll give this floor a haircut. And we'll take away some of the extra planes. Oh, looks like I'm missing one little edge there across the top. These 2 planes happen to just not quite meet in full here. So I delete these points. This roof is now complete. Ta-da! You can see how on these lower roofs, if you wanted hips, you could create just smaller versions of the exact same line. I could just come up here and grab some smaller lines and copy them up a little bit onto the buildings. So just eyeballing a short distance, I am copying this angle here, this angle here. It really is a very flexible philosophy when you are dealing with right-angled floor plans. And in a future video, I will also cover the drawing of roof planes for non-right-angled floor plans. It's similar techniques, but requires slightly better triangle visualization. So this particular edge, I think I kind of guessed wrong. This line is too short for its use case. So I'm going to go grab the bigger one. That's too long. If I copy it, it's going to bust through my building in annoying ways. So I'm just going to click a longer length along its length and then copy that there. So there's going to be a bunch of fun intersections that happen there. I will do the same thing along this direction. I'm almost done adding all these secondary roofs. Looks like I missed one opportunity in the back corner here. No, I'm just missing a 4th direction. So all my use cases for this direction, We'll come over here. This one looks a little too short. This is a good opportunity, just barely too short. Good opportunity for me to show one technique of line drawing if I go to my line tool. When I have any line I want to align to that is not world red, green, or blue, simply clicking on 2 points of that direction will start to construct new affordances that match that line. So here we're seeing a compound intersection that makes my line become aligned to that stuff. So I'm now going to click a second time and I'm passing through the building. And I'll delete this point so it's united. Now, if I'm not mistaken, all I have to do here to make these intersections happen, like here's a fun complex one. I'm going to hide my roof with the hide tool. The hotkey is HI or the command is hide. I can now see the lines coming through. If I connect these two, I'm pretty sure the intersections did not occur automatically. Okay. Well, that is not too difficult. There's a reason for that. It's because they technically don't actually know about each other too well. But if I take this rectangle here and I run across this plane again, the fact that I used an edge that passes through 2 points they share caused them to reevaluate exactly what kinds of splits are needed. So if I come through here and I just drag this across to here, and I drag this across to here, we're now seeing that the roof is building up its understanding of how plane A meets plane B. It's causing a little bit of extra construction content that I'll have to just remove here. Don't need that. Don't need that. This is good because this represents where the exterior, flashing, for example, would exist. This line's not needed. I think this line was not needed. But now we're seeing two easy ways to misclicked, to complete the last side hips for this roof, if a side hip was desired. If it was, of course, a full, gable here, then we could just travel across. But similarly, I'll demonstrate a second technique for intersecting simpler roofs like this one. We know that in this circumstance, this point is very likely to be a 2-to-1 rise away from here. So the length of this wall, 4 feet, is very likely to be the length of the green projection to this wall intersection. And if we come up 2 feet, hey, look at that. The system is saying, yeah, go up 2 feet, you will intersect that ridge. So we've just built up a little triangle on the wall, didn't need to use the rectangle tool and intersect things. We just built up a more specific understanding of where this point meets the plane. And we are working on making our lines and planes intersect a little more intelligently, but here it doesn't take too long before you've built up the exact point here from its two constituent vectors, the 4 feet along green and 2 feet along blue. So I'm deleting this, and this is now that part of the interior wall that will be bounded by the roof awning space on the second floor. And oops, it looks like I may have deleted, oh no, I just hid. When I type UH for unhide, I will get back my plane. Same deal here. I measure this, looks like 6 feet. So I'm coming over 6 feet and then up 3 feet and then across until I bump into this line. And then I'm gonna finish bounding the rest of my bump out roof here. I will hide this plane and delete my little construction line and unhide the plane again. One more time for good measure. Measuring this, we got 3 feet, 3 feet, coming up 1.5 feet, coming back down. We've got ourselves 2 triangles. If you've noticed that these points are coincidentally a perfect 6 feet apart, which with triangles is sometimes surprising, it's actually, because everything we've modeled is in, I've modeled a floor plan here that has nice round foot or inch distances, and because everything is rising with equal proportion, this point having been moved 4 feet aside from this one, this point, sorry, 3 feet, same thing here. This length of 6 is really just this length here, minus 3 feet, minus 3 feet. So because all the compound vectors are nice round numbers, these points, even though they're results of triangles, end up being nice round numbers in the same vector direction. Anyway, kind of using big words, talking about geometry like a mathematician would, but really that's what you're doing when you're building a building. Building a roof is one of the most complicated parts of the design. Laying out your walls is the fun, easy part. Like, getting this part, if I hide this and look at the building, getting this part took a minute and a half. Getting the roof took 15 minutes for me, and I'm experienced. So if you have any questions about this video or about the techniques used to model roofs of this type, you can definitely write to us at support@modumate.com or info@modumate.com, and we will respond to those questions as best we can. We may even film new videos for our tutorial library based on your questions. I also, I think shortly after this video, we will publish symbols of this content into our marketplace. So if you go to the symbol tool, which is found here at the bottom of our kind of BIM assemblies, the symbol tool, which was released in late 2022, is a tool that allows you to instantiate different groups of massing graph content. And so if you open up the marketplace, you will find, for example, cabinets here right now. But shortly after filming this video, I will create symbol content packs that include all of the right sloped lines for a 6 to 12 roof, and a 4 to 12 roof, and an 8 to 12 roof, 10 to 12, 2 to 12, 12 to 12. All the common kind of ratios for roof slopes will need a content pack that basically includes these 4 critical lines for making your hips and valleys, and then probably some 2-dimensional versions of the same thing, where if I draw a line along green and connect this, and then connect this, these 2 lines would be the ones you could copy into any position where you wanted a gable. So, although I'll do it differently here, if you wanted a gable on this roof over the garage, I'm going to use the move tool and move that point until it is coplanar to this face here. But these 2 lines, if you were drawing it the first time as a gable, could be created by copying this line right into place here, for example. So the construction lines you'll need for hips and valleys are these 4. The construction lines you'd need for gables would be these 2 in whatever cardinal direction. So I think that will be a set of assets you can go find in the marketplace shortly after this video is filmed, which today being, I guess the publication date might be a little bit different than today's date, so it's not important what today is, but good luck building your roofs. We are here to support you, and Modumate does make for a more intuitive roof massing process than other software that requires you enter in all these slopes via parameters and answer questions in some kind of long questionnaire about how all these intersections work. And hopefully it leads to a frictionless experience building your roofs with Modumate. Thank you for your time.